Okay, let's start. So, this session is starting for the Hadoop fundamental concept. Okay, so because we have a different phases are there in the complete big data training. Okay, so in this 2 day session, I will be covering the Hadoop components. Okay, so first we need to install Hadoop, and then we have to do practice for the Hadoop command. So different components are there. So as per this syllabus, right, we will go through the individual component one by one. Okay. So first I will be starting from the very basic fundamental of the big data. Okay. So most of the people may know already big data. Okay. So I'm just starting from the scratch. Okay. If anybody has questions, can ask the question in the middle also. Okay. Or at the end of the session can ask. Okay. So has anyone question in the beginning before starting? All good, yeah?
Hello.
Yes, yes. Who is
Hello.
yes, who is speaking? Yeah, hello. Yeah, if
Yeah, I
somebody
can hear you.
please mute it. Okay.
Yeah.
So that everybody listen. Okay. Okay. Yeah, I'm recording. Okay. Don't worry. Yeah. But this recording will be on the YouTube. Okay. I will provide on the YouTube. Okay. Yeah. So first
Sir
we are
Arvind sir.
yes, yes, yeah.
Hello.
Yes, yes,
Sir,
yes.
sir, before starting question, I mean starting the session, I have one doubt, sir. Actually, sir,
Yes.
regarding these codes, after two demo classes, so after that, what is the process, sir? Timings and all. If I
I
miss
will
some
tell. I will
section,
tell you. So that is not a problem. Okay. I will tell the all the. Okay. So 1 week session is free. Okay, 2 weekend session. Okay, and next complete for 5 days session.
okay, sir.
Okay, so first we start as per our curriculum, right? What is big data? Okay, so we all very well aware of the big data term, right? We are hearing lot big data in past 5 6 years, lot, right? So big data is basically a term, and please mute, right? Who is not speaking? Okay, so that disturbance should not be there. So big data is basically the term, right? The data is a very huge amount of data. So what is the definition of the huge amount of data? So even I can say like a 1 GB data is a huge amount of data. Okay. So I say like a 1 GB data is a huge amount of data, or 1 TB data is a huge amount of data. So there are the some characteristics are there of the big data. Okay. So these are the 4 characteristics. Okay. Velocity. Okay. So when I say the data is very fast paced, the data is generating. Okay. So if I am just saying like 30 minute, the data is 12 TB data is generating, that is the sensor data. Okay, that is the sensor data is generated by the flight. Okay, the sensor data is a raw data, and this data is a huge amount of data. In 30 minutes, it's a large volume of data. Okay, so when I talk about volume, right? So when I say a large volume of the data, and which is coming with the very fast speed, right? So the velocity is very high. So this is the one characteristics, right? Characteristics of the data, which is talking about the data is a big data. Another one is the volume, right? So when I'm talking about in the 30 minute, I'm generating a 12 terabyte data. So volume is high. So volume is a 12 TB data. So this 12 TB data is a huge amount of data. Okay, so that volume is high. Okay, so volume is high here. Okay, so that is basically another characteristics of the big data. And we can say variety. So when the data is coming in the different form, right? We know, right? Data is a structured data, semi-structured data, unstructured data. I will talk about these terms. So structured data is a data is like a simple text data or number data, date data, so which is having the dimension. So if I talk about this is a string, right? So this is having the fixed dimension. I can measure this data, I can understand this data. Okay, and when I talk about unstructured data, okay, so unstructured data is like if I say audio, video, image, so I can analyze the data, but I need some tool, right? So some audio, video, image processing tool is needed. Okay, so audio, video, image processing tool we needed. Okay, and these tool will be analyzing the data. Okay, so the data is coming different varieties. Like I can say the data is from the different sources. So here I'm talking about the data is coming from the different sources, and these sources can be from anything, like it could be a file system data, SQL DB data. So whenever we are writing the ETL pipelines, right? So we are analyzing the huge amount of data, and these data could be from any source, file system, SQL, NoSQL, okay, REST API, right? So we have to find the source of data. We have to find the source of data and find the format of the data. Then we have to write ETL pipeline code. Okay. So Hadoop is providing more of the storage part, right? Like basically Hadoop file system, I will talk about later. Okay. The Hadoop file system is having a large block size. So what is a term is a block size, memory, all these things will come. Okay. First, we are trying to understand what is the definition of the big data. Okay, so we are talking about, we are going to analyze the what we are going to do in the data engineering in the big data. We are doing the data analysis, right? Data analytics, right? We are doing the data analytics. So we need to understand if I want to do large amount of data analytics, then I'm going for the big data tool. And one big data tool is Hadoop. Hadoop is a one big data tool. Spark is a one big data tool. Okay, this is in-memory computation tool. Okay, so Spark is another big data tool. But Hadoop is having hdfs, Hadoop file system. So Hadoop file system is a storage component, and mapreduce is a processing component. That is similar to the Spark. But there are some limitation of the MapReduce, so that people are using the Spark, because Spark is providing more faster way the analyzing the data, computation of the data. Okay, because it's a in-memory computation data. We'll talk about that later. So we are talking about the different types of data. Okay, and another one is a veracity. Veracity is another term, right? We define. So veracity, we define a term that is defining the truthfulness of the data. So truthfulness of the data is like whether data is correct or not. Because if the data is like messy data, or it's a null data, missing data, so that data is not useful for us. The data is which is has the meaningful, right, characteristic. Okay, or we can say the data has meaningful information. Okay, so that is our data is a truthfulness is there. Okay, so data should be correct. Data should be correct. Okay, so these are the characteristics of the data. We identify the data is called big data. Okay, now next thing is types of data. Okay, so types of data, there are the three again. We have different types. Okay, so structured data is where we have the fixed dimension. Fixed dimension, I'm talking about the data which is completely structured form. Okay, I say data is in the RDMS database. Data is in RDMS database. So RDMS database tools, right? We have the data is a structured data. So these data is like a different data types. Data is there, right? Date data is there. String varchar is there, right? Varchar is there. Integer number data is there. Numeric data is there. So these data are the having fixed dimension. So we can easily measure this data. The definition of the structured data is we can easily measure this data. Another one is unstructured data. There is no fixed dimension, and we need some specific tool to analyze this data. Okay, we need some image processing APIs tool or audio, video, image. So all these tools can easily measure those kind of data. We need some specific tool to measure this unstructured data. Does Spark run on top of the Hadoop system? See, Spark is independent of Hadoop. We can use with Hadoop. There are the different cluster manager is there. So one cluster manager is Yarn, then we will be using the Hadoop as a storage. But when I'm using a cluster manager standalone or Mesos, any other cluster manager, so we are running Spark independent. So that is the reason MapReduce is having a one limitation is MapReduce cannot run without Hadoop because it is tightly coupled. Okay, because it is using only Hadoop file system data. Okay, I will talk about MapReduce. Okay, and Spark can run independently because Spark is like suppose my job doesn't have the data. It is very small data. So I don't need to keep the data in Hadoop file system and then I run my Spark job. So Spark job can run anywhere. Like it can just you have to install the Spark engine and Spark framework you have to install in your any local system or Hadoop or anywhere. Okay, depend on which cluster manager you are using. Okay, if you are using a standalone cluster manager, in that case, like when you are using Spark cluster manager, right? Cluster manager Yarn. So then it will be using Hadoop. Okay, that is a different cluster manager you are using Yarn. So Yarn cluster manager is basically Hadoop based. Okay, then it will be using Hadoop as a storage. Okay. Otherwise, if you are using cluster manager standalone, okay, so standalone is like any file system, okay, other than the Hadoop, it can be done. Okay, so another one type of data is semi-structured. This is very useful format of the data because most of the times we are working on the semi-structured data. So semi-structured data is like any file system data. So file system like CSV file, JSON file, okay, JSON file, XML, and some other compressed file format also there in Hadoop. Parquet. Parquet is a corner file format. We will talk about more on the Parquet, ORC, Avro. So these are the specific file format, compressed file format, and we can measure. We can use the analytics tool to read this kind of data, right? Okay, we will use Hive. So Hive we can read the data. So Hive is a SQL tool. Okay, Hive is a SQL data warehouse tool. So we can use semi-structured data, unstructured data, and structured data. So Hadoop platform support all types of data. Okay. So another thing comes in the Hadoop big data fundamentals where we are using the big data use cases. Okay. So nowadays big data is used in every industry, right? If we talk about airline industry or we are talk about insurance and medical healthcare or any industry, insurance, finance, okay, all industries are using because the data size is growing. Because we are not predicting like what the data size is today and tomorrow what will be the data size, we can't predict it. Because most of the times what happen, right, whenever the like our application is growing, right, our customers are growing, so data will grow, right? So we cannot know, right, what data size can grow, right? So we have our application very flexible that can handle large to large amount of data. Okay, so we are writing the applications in the using the big data framework, right? So Hadoop is one of the tool. So there are some set of components are there. So when I say Hadoop is not a one tool. Hadoop is a framework. So Hadoop is a framework and which is providing two core components. Okay, so two core components. So what are these two core components? So one core component is hdfs. So for any framework, two are the major things are there. One is a storage and second thing is a processing. So when I talk about storage, so storage is in Hadoop is hdfs. So Hadoop is not using local file system like our Windows or Unix. What is doing, like everything we are Hadoop file system is on top of the Unix and Windows only, but it is a specially designed file system which is handling a large amount of data. So how can I say this Hadoop is handling the large amount of data? What is the reason, right? What is the reason like these Hadoop people are saying, right? This HDFS is handling HDFS is handling large amount of data. What is the reason of that? Large amount of data. Okay. So here is a block size. Okay. One thing comes here, block size. Okay. So block size is in Hadoop file system. In Hadoop file system, the block size is 128 MB. Okay. The default block size. Okay. First of all, what is the block size? Okay. Generally, we say the data in the terms of MB, GBs, okay, and TBs, petabyte. Okay, so these terms we call it data size. Okay, when I say data size we talk about in the MBs, GBs, TBs, petabyte, exabyte. Okay, so these are the zettabyte. Okay, so these are the terms are there for measuring the data. But in the Hadoop, in the Unix or Windows, when we talk about two major operating system, Unix and Windows. So Unix and Windows, they have Windows. So Unix and Windows, they have 6 KB block size. 6 KB block size. So you can say 6 KB block size means one block is 6 KB. Okay. So when I say one block is a 6 KB means if my data is GB, so it will take a huge number of blocks, right? So when the number of blocks will be the huge, right? So it will be taking a more time to read the data or write the data, right? So that is the reason Unix or Windows are not good fit for the very huge amount of data to process. They can store it because the disk size is there, right? So we can store the data in the Windows and Unix, but we cannot process, we cannot read very huge amount of data because of the block size is very small. So what Hadoop designed block size 128 MB. So this 128 MB, if you compare with the one block size 6 KB, that is really huge, right? And it will have less number of blocks. So it will be more faster to read data as well as it will be process the data. Okay. So in the design of the Hadoop file system, this is also configurable, right? If I want to make it this block size 256 or 512, I can make it because in the configuration file, or I can change command line tool, we can change this block size. So once this block size change, so automatically the file is taking a less number of blocks. Anybody is asking any question? Okay, so this number of blocks, right? This number of blocks depend on the block size. Okay, so the block size is either 256 or 512, depending on the block size. The number of blocks will be decided. Okay, the number of blocks will be decided. So that is the one reason, like why we call it Hadoop is handling the large amount of data. This is the reason the block size is too high, and this number of blocks will be less, and the number of blocks will be less. So data will be read faster or write faster in the Hadoop file system. Okay. Now we come to back to here, like that there any framework has a two core component. Okay. So Hadoop has provided one core component storage, and this storage component is storing the large amount of data. So when I say storing the large amount of data, so it is storing on the Hadoop file system. So definitely this HDFS, which I'm talking about storage file system. So this storage file system, basically we have to move our data to the Hadoop file system. Okay. So suppose my data is in my local file system. Okay. Suppose my data is in my Linux or Windows file system. Okay. Then I copy or move to Hadoop file system. And then I can do my analytics. Okay. So this data will be permanently stored on the Hadoop file system. And for processing in the Hadoop, there is a mapreduce is another core component. So mapreduce is nowadays nobody is using because mapreduce is completely Java based framework. So Java based or Python also we can write. So it is basically writing a use line of code, writing use number of lines of code. Okay, so that is the reason people are not preferring. And another thing is it's having a dependency on Java. So is there any advantage in using a small block size in Hadoop for parallel processing? So we always go for the large block size because there is no point to use the small block size, because parallel processing is not related with the block size. Okay, so parallel processing is it's a part of the uh, processing part, right? Like our parallelization part, right? How can we distribute the data into the partitions? Okay, so when the block size is read, it is divided into the data into partition, and that will do the parallel processing. Okay, so large block size, first we have to read the data. Before processing the data, I need to read the data. So the number of blocks will be less. So I will be read data faster, right? And I will, if it is a Spark, then it will keep it in memory. If it is not a Spark, it will do the disk processing, right? It will read the data from the disk and then process memory, and again data read from the disk, like that it will do. If it is a MapReduce, it's a batch processing. Okay. So when I say Hadoop has some more component also there, apart from this storage and the MapReduce component. So if I say Hadoop is having an ecosystem, right? So Hadoop ecosystem is a set of tools are there. Okay. So still this Hadoop is not completely replaced, because Hadoop is storage part will be there also. If I'm going any cloud, okay, set of tools are there. So what are the set of tools are there? So hdfs is a storage tool, mapreduce is a processing tool, hive is another analytics tool. Okay, and if I say hbase is a NoSQL database. So we already know there are so many other NoSQL database are there in the market, right? Mongo, Cassandra, right? So similar to other NoSQL DBs, right? So HBase is one of the NoSQL DB. It's a column family database in Hadoop ecosystem. So MongoDB and Cassandra are the some other, but these are the out of the box tool. But HBase is a part of the Hadoop ecosystem. So integration, like when I'm using HBase or when I'm using Mongo, the difference is Mongo needs some integrations. Okay, but HBase is a part of Hadoop ecosystem, so it will be easily integrated and we can use it in the Hadoop ecosystem. Okay, so HBase is one of the tool, and Flume is Flume and Scoop. These are the two tools for the ingestion of the data. So when I'm talking about, I want to read the data from the different sources, right? So how the data will come into the Hadoop file system. So either we can use the Flume or we can use Scoop. So what is the difference in Scoop and Flume? So Scoop is for structured data. For structured data injection, so we use the structured data, like data is from the RDMS database. Data from RD. So when I'm saying the data is coming from the any relational database management system, any SQL database, Oracle, MySQL, SQL Server, right? So it will be using the Scoop. Okay. Nowadays we are doing mostly ingestion with the Spark, right? Because Spark is a ETL tool. Okay, and Spark is doing not only the ingestion, it is doing the analytics also. So Spark can do ingestion plus analytics plus loading data into target. So end-to-end ETL pipeline we can design through the Spark. Okay, but Scoop is only doing the ingestion work, right? It is just ingesting data, nothing else more than that. It will bring data into Hadoop file system. Okay, so when I'm talking about these all Hadoop component, these are tightly coupled with the Hadoop. You need a Hadoop should be installed on each machine in the cluster. So when I'm talking about Hadoop, Hadoop is not a single machine. It will not be on the single machine. It will be a cluster. Like basically I say, what is a cluster definition and what is one node? One node is means a machine. Okay, when I say machine, and this machine has some hardware, right? Hardware and CPUs, hardware like memory, right? All those things. And we have a installed operating system on top of that. And on top of that, we installed Hadoop. So Hadoop is needed on all the machine in the cluster. Okay. So when I talk about the cluster, we hear a lot many times like cluster. Like generally the big companies have the big cluster, right? They say they have 120 nodes cluster. So what is 120 nodes cluster, right? So if one node they are using, okay, 2 TB data, 2 TB disk size, okay, and they say 64 MB RAM, 64 GB RAM, right? 64 GB or 128 GB RAM. So the total RAM will be the multiply of the all system, right? So when we talk about the cluster means your data will be shared across the machines, across the node. Okay, so that is the advantage of the cluster. And the cluster has two types of scaling is like horizontal scaling is there. So what is a horizontal scaling and what is a vertical scalability? So two types of scalability is there, vertical and horizontal scalability. So when I talk about in the Hadoop, right? So there is a horizontal scalability. So horizontal scalability is like, suppose you have a 10 nodes now in your cluster, okay? And tomorrow your data size is growing. So you need a more number of nodes. You need a more number of nodes, right? So you will add those nodes, okay? So that is horizontal scalability. So adding number of nodes as per requirement. So you are scaling your nodes in a horizontal way. Okay. Vertical scalability is in one node itself, in one node, okay, one node, you have some hardware. Okay. You talk about those hardware like CPUs and memory. Okay. And disk. CPU, memory, and disk. Okay. These are the three major hardware, right? We use CPU, memory, and disk. And if you are trying to increase these hardware, okay, so there is some limitation because maybe like a CPU processor is processing unit is not allowing more disk and memory, right? So there is some limitation. Okay, so the vertical scalability is the limit is there, limit for the hardware. Okay, so that is vertical scalability. So if I talk about what are the vertical scalable system, right? I say SQL database. So SQL databases or like I can say the application with data cannot be shared across the machine. Those are vertical scalable. So SQL databases are example. If I say any SQL databases like MySQL, Oracle, these databases are vertically scalable because these are not horizontal scalable. But nowadays, these databases also making it more changes, right? And then they are becoming horizontal. Okay. So the problem with these databases is like if you have the installed this MySQL Oracle on one machine, so you can't share data across the machine. Can you explain executor code? See, this part is the Spark related. Okay, I'm not talking about the Spark now. I will tell about when I will be doing the Spark. Okay. So this executor core, executor memory, this is related to Spark, like how we can um, define, right, how many number of core. So core and memory is the part of a general machine, right? Like we have CPU core, okay, and we have memory, but executor is a part of Spark because it is executing your task, right? So when we are allocating the cores, executor cores like CPUs to the our executors or memories to the executor, so that becomes the executor core and executor memory. So how much cores, how many cores, and how much memory is needed by the your executor, that is defined by the executor core and executor memory. So horizontal scaling and vertical scaling. Okay. So Hadoop is the horizontal scaling. Okay. So Hadoop framework is a horizontal scalable and it is a distributed. So when I talk about the horizontal scalability is there, so it is a distributed. So distributed and data is shared and across the machines and we can add the number of nodes. Okay. So when I talk about the Hadoop ecosystem, so in Hadoop ecosystem, like a Scoop is a one that is used for the ingestion of the data for structured data, and Flume is other tool for the ingestion of the data, but it is for semi-structured and unstructured data, semi-structured data and unstructured data. Okay. So when I'm saying the data is coming as a streaming data, right? Data is coming streaming data or data is coming as a files data, JSON file, CSV file, or different files data, so we can use the Flume. So Flume has the source, channel, and sync. Okay, so these are the components are there in the Flume. But nowadays, everything we are ingesting through the Spark. So Spark is now a very common tool for all types of ingestions, right? All types of data we use the Spark. Okay. Anyone has any questions so far? Can ask. So far, I covered. Okay, everything is good. Okay. Yeah, course related things I will discuss later. Okay, because here this is nothing related to Spark. Okay, so I'm talking about here. This is the Hadoop component. Okay. So first,
Hello.
yes, yes.
Sir, I have a question. For
Mhm.
example, there is the 280 MB of data, but the block size is 128 MB.
Mhm.
Okay. So here I think it will create the three blocks. So, but
How much is the total size of the data? How much total size?
280 MB.
280 MB. Okay. Mhm.
Yeah. And block size is 128 MB.
Correct. Yeah. So three blocks will be there. Mhm.
Yeah. So, can you tell me about what happened with the 24 MB of data? Because if there is
Okay.
the
Okay.
yeah.
Actually, it will be divided into the three blocks, right? Because we have 128 MB block size. Okay. So the remaining, okay, because we are saying 24 MB will go to the third block, but whatever the remaining is there, right? 120 MB data is remaining, right? So that one will be allocated to another one. Okay. Another file it will be. So this all defined by the, actually Hadoop has the metadata component, that is a name node. Okay. When I say, okay, I will talk about this because basically it's related to metadata related thing. Okay. How the, when I say like 64, 128, 128, 256 and remaining goes to the third block. So that third block will not be empty also completely. So that third block will be used by the another file. So who is all this taking care of? That is the name node is taking care. So name node is a part of Hadoop file system, HDFS, that is taking care of everything. So whenever I'm requesting to read a file or write a file, I don't need to worry about where the data is stored because I'm not looking for that. I'm just looking for whenever I request for reading a file or writing a file, I should get the file or I should write the file. That's my intention, right? So when the internally how Hadoop is managing, because it is managing internally, like it is allocating the IPs. Okay, suppose I say, because we are working the Hadoop in the cluster environment, right? Cluster environment. The cluster environment, there are not a single node. There are multiple nodes are there, right? So when the data allocation is happening, right? So metadata is stored in one machine only. That is called the name node machine, metadata storage. Okay. So metadata storage is the data about data. Okay. Suppose I say I have these block information. So what will be the information? The block ID, some block ID will be there. Okay. I'm allocating the block ID. So I can recognize the block ID is there. I say which IP the data is stored. Okay. IP means data node machine. So data node is a machine where is the actual data is stored. So in Hadoop, one machine is particularly dedicated purpose is the for storage only, metadata storage, and that is called name node machine. Okay, so one machine is a name node machine that is storing the data, okay, metadata, and that metadata is deciding where is your uh, different blocks are there. So the complete file is not saved as a one single block, right? Because it is not possible, right? Because it is divided into, and these blocks are distributed into the number of data nodes. And whenever it is going to read, right, when your name node will give this information to the client, right, who is accessing the file, they can directly read these IPs. Okay. So the client is some user, right? User or client. Okay. So user or client, I say the end user. Okay, who is requesting the file, reading file or writing file. So whenever the client or end user will find this IPs of this data node, okay, so they will directly start reading the data. So this is called read and write anatomy, okay, write and read anatomy for reading files from the Hadoop files. Okay, so this way it is doing internally. So there is a concept when I talk about the MapReduce, then the concept of input split, okay, input split and the record reader, okay. So whenever the data is going to process, right, so that time it will be this block is a physical and input split is the logical division of the data, okay. So when we say like, okay, this is physically I can understand, okay, total number of blocks will be 3, but how the MapReduce is reading the data, so there is a input split record reader, okay, this is a record reader concept is there. So that way it is reading the data. Okay, I will talk about in the MapReduce how the data is distributed and how the data is being read. Any other question? Okay, so here I was talking about the Hadoop component. Okay, so first like a first day session, right? We have a target of hdfs and MapReduce. Okay, the core component of Hadoop. Core components of Hadoop. Okay, so we need to understand the architecture of the HDFS and Hadoop architecture, because when we are going to start learning or working in the Hadoop environment, right? And Hadoop will not be replaced. I'm telling about this HDFS because even we are talking about too much about the cloud. We are saying different clouds are there. Okay, so clouds also providing the Hadoop environment. Every cloud has one Hadoop environment. If I say the AWS cloud is providing EMR, okay, elastic MapReduce. So that is the Hadoop Spark cluster. That is Hadoop Spark cluster. So whatever setup I'm doing locally, right? Whatever setup in my Ubuntu virtual machine I'm doing for this Hadoop component, same, I will get it ready-made over there. Or I can use Cloudera. Cloudera is also ready-made. Okay, now Cloudera is on premises also there and on cloud also there. So 2 version of Cloudera is there. So whoever wants to use Cloudera on-premises version on the cloud, so they can go for Cloudera cloud version. Cloudera cloud version. So cloud version is the, and this is hosted on the AWS only, because Cloudera doesn't have its own cloud. They are using internally some cloud. Okay, so they are using AWS cloud for hosting the data for the storage purpose. Okay, but on the top of the cloud there is a EMR. EMR is a Hadoop Spark cluster. If I talk about Azure is having HD inside. Okay, HD inside is the Hadoop Spark cluster. In GCP is Dataproc is there. So Dataproc is a Hadoop Spark cluster. So it will not be completely eliminated, right? We can use some other analytics tool which is not using the Hadoop, right? Like in AWS we have AWS Glue is there. That is a Spark. We can run the Spark. Okay, directly we can run the Spark. Okay, but there is no Hadoop component you will get in there. But EMR you will get complete package, right? You will get SDFS, MapReduce, Hive, HBase, and you will get a Scoop. You will get Plume. Everything you will get because it's Hadoop is there and Spark is also there. So EMR is like costly service, right? As compared to Glue. Glue is like you can write a standalone job. Like when I'm talking about the standalone, when I'm not using the Hadoop file system, right? So I can use the Glue. But when I want to use Hive, I want to use Scoop, then I have to go with the EMR only. So I can say, right, this Hadoop component completely can not get rid of, right? Because even the cloud is also giving us support of the Hadoop environment. Okay, but depend on the requirement, right? If your data analytics is, so the metadata keep track of the block storage location. Yeah, everything is, even the failure happen also. Like suppose your data node is goes down or your name node goes down. So this all things will be keep track, right? So there is a 2 copies in the name node is there. So one is a edit log file and one is a fs image file. So one is a memory copy and one is a disk copy. So everything is completely high availability is there. So high availability is a main factor, right? So suppose my system is not highly available. So what is the use of my system? if any website is not available 24/7, so that is not a use of the website, right? So that is same thing we say, if my system is not highly available, it's no use, right? So high availability is there, so there is a replication of the data. Okay, that is the reason we are using the cluster we are using, and cluster has nodes, right? So if one node goes down, so another node has the same copy of the data. So that is called the replication. So slowly these terms will come: replication, high availability. So you need to understand Hadoop architecture, then you will have more clear understanding about how Hadoop file system works. Okay. Okay, let's first let's start the understanding of the Hadoop file system. Okay. Hadoop architecture. First, we go to Hadoop architecture. So Hadoop has two core component I talked about. Okay, HDFS, and HDFS is further two core component. One is a name node, and second one is a data node. So when I say name node, and one more is there secondary name node also there for high availability. Secondary name node. This is for high availability. If name node goes down, so name node is a single point of failure. So name node is single point of failure. So if name node goes down, so entire cluster will be down. You can't access any data because all the data information, metadata information in the name node. So because name node contains metadata, which is the data about data. Okay, which is information about your actual data. Okay, so when I say data node is containing actual data of files. Okay, so it is containing actual data of your files. Okay, and that is your data node. Secondary name node is a backup of name node. Okay, it is a backup of name node. Okay, so whenever you are installing the Hadoop, so there total 5 services come. So what are these 5 services? One is the SDFS. These are the name node service. Okay, another one is the data node service. Okay, third one is the secondary name node service, and 2 are the processing service. Okay, these are the 3 storage service, SDFS, and 2 are the processing service, that is the mapreduce service. So job tracker, okay, we call it resource manager service, and node manager service. Okay. So whenever you are installing Hadoop, when you install Hadoop, so these total 5 services will be installing Hadoop. Okay. When you are manually installing Hadoop, so you will see these services are there, and you have to start the Hadoop by command start all.sh. So when you run the command on the $shell, right? So start all.sh, then you will see these 5 services keep running, and then only you can use any of these components, SDFS component or mapreduce component. So secondary name node is a backup of the name node. It is if any point of time your name node goes down, but some problem with the secondary name node is it takes a 30-minute time to sync the data, because how can I say whatever metadata is there, the same metadata will be here, right? So it needs to sync up, right? So it takes not every minute, right? It is 30-minute delays is there, 30-minute syncing sync time delay from name node to secondary name node. Okay, that is the reason, like, you will not get the latest updated request. So suppose this name node goes down, this secondary name node will act as a name node, but it has the same configuration, whatever configuration. And one more thing is, we say Hadoop needs commodity hardware. What is the term? Is the commodity hardware. Commodity hardware is the cheap hardware. Okay, so if you are setting up the Hadoop infrastructure, right? Suppose you're saying I want to install my Hadoop in my setup I want to do. So you don't have more cost. Why you don't have more cost? So Hadoop is suggesting you can use cheap hardware because Hadoop is providing high availability, reliability. So reliability, right? Hadoop is providing high availability through the cheap hardware. Like if you are using the cheap hardware, that is fine because Hadoop is not complaining, because Hadoop is having high availability concept in the data nodes also. High availability in data node. Suppose one data node is down. Okay, one data node down. The other data node has the same copy. Data node has same block of copy. Same block of copy. And this block of copy will be accessed when the one node is down. So the other data node will be accessed. Other data node will be accessed. Okay, that block of copy. So who will be deciding that this data node is down, the other data node? So this is all decided by the name node. Okay. So in this architecture, so cheap hardware means like you can use commodity hardware. You don't need to invest much on the, default replication factor is 3, but you can change it because this is configurable. So this application factor, I can make it 5 or 7, depending on the how critical my data, right? So I can change. So there are the two ways are the changing. One is the configuration file, XML file, you have this. So initially, whenever you are doing installation, you will get a default replication factor you can set there. The default replication factor, you can set suppose 3 in your XML file. Okay. So in hdfs site.xml file, hdfs-site.xml file, you set it in the beginning while installing. But after that, you found, okay, some particular file need more replication factor. Okay. So in that case, there is a hdfs dfs minus setrep command is there. So you can give 3 to 5 replication factor you give and give the file path. So when you give the file path, that particular file path, particular file only, this replication factor 5 will be set. So that is the advantage, like the whole system, the replication factor is 3, but only particular file, the replication factor is 5. Okay. So that way we can change the replication factor. So here we are using the commodity hardware. These are the cheap hardware, but the name node machine should not be a commodity hardware. Why? Because it is highly configurable machine. Because if I keep this machine as a cheap hardware, so my system will not be reliable. Okay. Highly configurable means very high configuration RAM, CPUs processing should be very, very high. Okay. So that is the reason if you are setting up the Hadoop infrastructure, right, in your environment, right? So the cost will be, it is an open source. First of all, we know, right, there are the Hadoop is an open source tool. Okay. Second one is it is flexible. So flexible means it can read different types of data, right? We already talk about, right, structure, semi-structure, so all type of different data it is reading. Okay. So it is flexible. Economical. Why it is economical? Because it is basically it is a cost is the less, right? So economical is there. So these are the features of the Hadoop, like these are open source, flexible, and economical and cost effective. Okay. So when I talk about this name node machine should be highly configurable because it is storing metadata. And this metadata is like always available every time. Okay. But if this name node goes down, so who is the backup is there? So secondary name node is a backup. Secondary name node is backup. But there is a Hadoop 2.x and 3.x. Okay, the newer version of Hadoop, the 2.x and 3.x. So there is a standby name node concept is there. Standby name node. So there is a one passive name node is there. Standby name node. So there is a passive name node is there. There is a passive name node. Okay, which will become active. When active name node is down. So in Hadoop 2.x, active name node down. So in Hadoop 2.x and 3.x, the multiple name node concept came in picture, right? Because when they realize it in Hadoop 1.x, this secondary name node till Hadoop 1.x, even 2.x is there, but it is not used. Okay, because everything is done by the standby name node. But Hadoop 1.x, when I say Hadoop 1.x, there was no concept of standby name node. Okay, high availability through the standby name node. So only secondary name node is the option. Secondary name node is the option. Is the only option. Okay. So when they provided this standby name node, so this is the passive, but it will become active when the active name node is down. And active name node is down. Okay, and it will take a minute time. It will take minute time to serve the request. To serve the request from the clients. Okay, serve the request from the user. Okay. So and how the data is syncing. So there is a third journal node is there. The journal node is one node which is a mediator, right? Which is a mediator between active and passive node, between active and passive name node, and that is syncing the metadata, syncing metadata. So metadata is more important than the data, because if metadata is not available, your actual data cannot be accessed. Is there any use case that justify the use of the? See, now Hadoop 1.x, everything is available in the 2.x and 3.x. So I will say like nobody will go to use the 1.x. Okay, and 1.x, the I'm talking about the resource manager and node manager in Hadoop 1.x. These are called job tracker and task tracker. If you heard about job tracker and task tracker, okay, so job tracker is called job tracker, which is now in the 2.x is resource manager. Okay, and task tracker is basically executing the task. Okay, so this is in node manager. Okay? But job tracker was not managing the resources. Okay, it has the only responsibility of assigning the task to the task tracker. Okay, so this Hadoop has the architecture master slave architecture. So master slave architecture is like the one master and multiple slave node is there. Okay, so when I say in HDFS, so HDFS, the name node is a master, name node is a master node. Okay, so when you are defining the architecture of the Hadoop file system, right? HDFS, so you say name node is a master node and data nodes are the slave nodes. Data nodes are the slave nodes. Okay, and master is how master will come to know all data nodes are alive or not. So there is a heartbeat mechanism is there, heartbeat mechanism between name node and data node. So any point of time, like every 10th of second, right? 10th of second, name node is sending a signal. Okay, name node. So these are all things happening internally. We are not taking care of this. Okay, 10th of second, name node is sending signal to data node. So if any data node is not running, right, or alive, okay, so it will not send back the acknowledgement. Okay, so name node will come to know which data node is not alive. Data node is not alive. So it will assign another data node, okay, to the client. Assign data node, another data node to the client for the same block of copy. Same block of copy. So this thing, this heartbeat mechanism is keep running, but this thing is like if the assignment process will be done at the time of reading and writing. Okay, but this heartbeat mechanism will be always keep running. Okay, and the name node will be keep tracking of which data node is alive or which data node is not alive. It is keep tracking of the this information, right? Okay, in the metadata. Okay, and accordingly it will give the information to the client or user who is going to read and write the data. Okay, so this heartbeat mechanism is there. And when I'm talking on metadata, so metadata is information about the data node. Okay, so what data, what block is there and which node the block is available. So that information is there as a term of metadata. So when I'm saying name node configuration should be high, because of it should be highly available, and the metadata is a small piece of information, right? So that will be in a huge amount, right? So suppose for one block, 1 KB information, one block, I'm just assuming it, right? 1 KB information. Suppose there are the thousands, millions of blocks are there. So it will automatically increase the size of the metadata, right? So increase size of metadata when number of blocks will be more, number of blocks. And number of blocks will be more when the data is growing more in the file system, Hadoop file system, when you are copying the more data, right? So automatically the number of blocks or large size of file, TBs or GBs or files you are storing in your Hadoop file system. So automatically the number of blocks will be increasing and then your metadata size is growing. So if our name node is not highly configurable, so we will get the trouble. Okay, so these are the architecture part. Okay, so when I'm talking about the data node, so data node is a machine, right? Node which has actual data, right? Like files data, okay? Files data, okay? That in blocks, okay? So in the blocks form, it is stored the data, okay? So name node is controlling the data node, okay? And the resource manager is the master of node manager, So every machine, every data node machine has one node manager, because who will be processing the task? The data node is having the data, but who will be processing the task? So one node manager will be there. Every data node has one node manager that will be processing tasks assigned from resource manager, okay? And resource manager is getting information from the task from name node. So name node will be instruct to the resource manager, okay? And resource manager will give the task and it will decide which because resource manager will get the information from the name node, which data node has data particular to that file, and that information when the resource manager will get, then the resource manager will assign, okay? So this is the like typical architecture, how, and the replication factor, right? So when I say replication factor, so the default replication factor is a 3. Like we keep it, maintain the 3 block copy. So if one block is down, in the one machine, so we can access the another block in another machine, okay? But there is a rack awareness policy is there, okay? First I explain what is a rack awareness policy. So rack awareness policy will be deciding the placement of the blocks, like how many blocks will go to the one machine, how many blocks will be going to the another machine for the same copy, okay? So rack awareness concept is, we say that our data is in the data center. So data center is the main storage area, right? There are the different racks are there. So racks is nothing but set of machines, right? Set of nodes. So suppose I say there are the hundreds of racks are there in the data center, and each rack has 10 nodes, 100 nodes, 20 nodes. So this is dividing of the. So if I say one rack has 3 nodes, okay? I'm saying one rack has 3 nodes. So the ideal way of the rack awareness is, right, basically we should keep it, the placement of the block is the same copy. So one block in the first node, any node in the one rack, okay? And other two blocks should be in another rack on adjacent node, okay? So if I say the first rack is down, so rack can be also not accessible. Suppose I say one rack is there, then second rack is there, okay? Second rack is there, third rack is there, okay? So when I say first rack is not accessible, because rack is having the different nodes are there. Suppose this rack is not able to access the node where my data is there, okay? So if this rack is not available, so I will not be getting my node access, okay, where my block is there. So second rack has my data. Okay, second rack is having the two node. So why I'm keeping adjacent? Because if one rack is down, so other rack has the two adjacent node, the same block of copy. So suppose the scenario is there in the second rack is having one node is down. One node is down in the second rack. The second adjacent node the second adjacent node has the same block of. Okay. But there may be a scenario I say the second rack is completely down. So in that case, I will increase my replication factor 3 to 5. I will increase the replication factor. So in that case, I have a 1, 2, 3, 4, 5. So third rack again 2 copy. So like this, I will maintain the copy. Okay. So if second rack down, so third rack, if the replication factor is 5, so third rack will have two different node adjacent copy, right? So one node has one block copy and the second adjacent node, another block copy. Yeah. Why I'm keeping it an adjacent node? So it will be more faster because because they have the routers, right? So they have routers and they can allow access faster. Okay. So second adjacent, another block copy. Okay. So this is a rack awareness policy. So they suggested we should keep it one rack, one node, one block, and same block will be in the second rack, the two adjacent node. Okay. Okay, so this rack awareness policy, some people ask because there may be different other policies also there. The one other policy is like you can say all three rack has three different node and three different copies. So there are the like if one rack is down, so second rack you will going to access, and second rack is down to third rack. But that is not a good policy, right? If all three rack, three different node, three different block of, okay, three same block of. So that is the replication factor. Okay. So metadata, we are storing the metadata, data about data. Data node is storing the data node actual data, and there is a heartbeat mechanism is there. Replication factor is there for the, and the high availability is there, and that the concept of the active name node, passive name node concept, standby name node concept is there. Okay, and these are the concept in the Hadoop. So Hadoop 2.x and 3.2x architecture is called YARN architecture. Okay. So YARN is a yet another resource negotiator. So sometimes people ask about YARN architecture. So when they say YARN architecture, this is the 2.x and 3.x has the additional like services they provided, right? Like the standby name node, right? So for the high available. Okay. Okay. So now we come to the installation part, right? Because we are talking about the HDFS and like MapReduce, right? So how to install the Hadoop and how to use the command. So next thing is in the HDFS, like once we cover the big data fundamentals, so in the HDFS, we need to learn the Hadoop commands. So Hadoop command, we need a knowledge of Linux, right? Because all the Hadoop commands are using the Linux command we have to use. Okay. So when I say if any Linux command is a CP is there, okay, or I say RM command is there. So in Hadoop, I will use the command Hadoop fs minus CP. Okay, Hadoop fs minus RM. So Hadoop is a file system, is a virtual file system. So we cannot go inside that. See, in the Linux, right? If I have a one directory, okay, I have a one directory. So I can do CD. I can go CD, right? I can say CD dir. So I can come inside the directory and I can create a file, okay, cat test.txt. I can create some file and then control D, I can save the file. Okay. So here in Hadoop file system, you can create file, but it is a virtual file system. So whenever I say Hadoop file system, some size of your disk is allocated to Hadoop file system, right? Initially, some disk size you are allocating. Okay, and this will be used for the Hadoop file system, but it is growable, right? It can be right automatically the data will be coming and it will take your disk size. when I'm installing the virtual box, right? When I say I'm doing the setup in my local here in Windows, so I have an option virtual box. So in this virtual box is using my system RAM and memory. Everything is taking my system RAM and memory, and disk also is in my memory in my machine, right? So as much as RAM and system memory disk I give, it will be more faster in my Hadoop, right, environment. Okay? I can do more faster processing. Okay. So it's a virtual file system. So whenever you want to see the data or you want to check the data, copy the file, so you have to use Hadoop FS or HDFS DFS. So HDFS DFS is the newer way. Just change HDFS DFS and then ls command. So when you do ls slash, so this is the root directory of the Hadoop. Slash means root directory. Okay. So root directory is like in the Unix file system has a root directory, right? Slash directory. So all the complete entire file system is on that root directory. And after this root directory, suppose you create your directory Hadoop fs minus mkdir and say slash test. So this test directory will be created. And now I want to see the files in this directory. So I will do Hadoop fs minus ls slash test. So every time you have to give the full path, complete path of your folder you have to give. Okay, suppose this folder is in another folder is there. Like I say test1 slash test2 slash test3. So suppose I want to see the file of the test3. So you cannot give directly only test3. So Hadoop file system will not understand. Because in the local file system also, in the Linux file system, either you do complete path or you go to the CD, right? Even if you try just in Unix, right? If you try ls test3, will it show the test3 in the test2 one? No, right? It will check in the local one. Okay. So either you have to do in the Unix or Linux file system also, you have to give either entire path or you have to go to CD. But here is no CD option, only one option, right? You can give the complete path. Okay. So this is the virtual file system. Okay. So when I'm going to install the Hadoop, right? So I will see this command and because when I'm going to process the data in Hadoop, I need to install Hadoop and then I can only use this command. Okay. So Linux knowledge is needed because all the Hadoop command is based on the Linux one. Okay. If you see cp, rm, mv, every command of the Linux is in the Hadoop. Okay. So whatever you can do for the Linux file system, your local file system, and then you can do same thing for the Hadoop file system. Okay. So for the installation, hdfs, dfs. Okay. See, command both are same, but actually the Hadoop fs is the older version. Okay. Previously, Hadoop fs is the command, but now is the command is the now you can use both also. Even hdfs, dfs is fine, and hdfs, dfs or Hadoop fs both are fine. But now the Hadoop people are saying you are using the command Hadoop command. So why you are using Hadoop? Because Hadoop has two components, hdfs and mapreduce. So when you are specifically using the hdfs command, so use this naming convention. This is a naming convention only, nothing else. Both command will work. Either use Hadoop fs or hdfs df. hdfs means I'm just specifically saying that this is my Hadoop file system command. But Hadoop fs means here the word Hadoop means is signifying here because Hadoop is not hdfs. It is the combination of the hdfs and mapreduce. There is no difference in the syntax. Okay, so okay, I'm showing in my cloud. Okay, AWS. I show the installation and then show the command. So first we have to create one machine. Okay, so EC2 machine. So we will see that cloud terms because nowadays it's very important to learn different cloud. Okay, but at least one cloud should be very strong. Okay, so you can start with AWS and then go further any other cloud. Okay, so we have to create a EC2 machine. EC2 is like a machine, right? A VM, we can say. it is having the hardware, CPUs, memory, everything is there. Okay. But we have to create a one EC2 machine on the AWS. Okay. So we have to launch the instance. So we have to launch instance. So when we launch instance, it is asking me what EC2 instance name you want to keep it. Okay. So I keep it some name. Okay. I'm choosing here Ubuntu. And now I'm deciding which Ubuntu version. So I'm taking here is the latest is a 22, but if you're doing VirtualBox Ubuntu installation, the 23 you can do. But here they have 22. So I'm using this. And this is very important, the instance type, because this will decide, right? Because this is a free tier eligible. So when you have a free tier eligible account, right? The 1 year account, right? So in that free tier eligible account, this T2 micro is free, like 750 hours you can use it. Okay. But if it is more than 750 hours month, like suppose you have a 2 instance and 2 T2 micro, and if those T2 micro instance, you will get maximum 750 hours. But if your total more than 750 hours, then you will be paid like some hourly billing. This cent is there, right? 0.016 USD per hour. That is 2 lakhs. Okay. So, but for the high configuration purpose, I always suggest use VirtualBox. Use VirtualBox and do setup in your local machine. Okay. Setup will be the same. Only thing is, instead of using the VirtualBox, I'm directly creating a new machine of Ubuntu in AWS Cloud. Okay. So, but if you are going to use it, this T2 micro one, it is having very less memory. Can you see here 1 GB RAM? So 1 GB RAM, 1 CPU, I cannot manage my Hadoop cluster on the Ubuntu in AWS. Okay, because this configuration RAM memory, right? This RAM and CPUs, it all depend on my machine. If my machine has 64 GB RAM, I can give as much as possible to my VirtualBox Ubuntu. If my CPUs are 28 CPUs are there, I can give 14 or 15, 20 CPUs I can give. So it is in my control. But if you are taking it higher instance here, you have to pay more. Okay, suppose I go here. This is a 2 CPUs one. This is a 4 CPUs one, 16 GB RAM. This is a 8 CPUs one. Okay, I'm taking this one. Okay, and I have to select the key pair. What is the key pair? Key pair is like a public private key. So you want to access your CPU, AWS instance from your machine, right? Local machine. So we need to connect to this key pair. Okay, so I'm selecting my existing key pair, or you can create a new key pair. This is all related to cloud. You can take any tutorial and then understand. Okay, so I'm just going to create a machine now. So my machine will be ready within 1 minute time. Okay, it will be ready. So here my machine is coming. So it is showing in the pending state. Whenever you are not using your EC2 instance, you should stop it. And you are not completely not using it, then you can terminate this. Okay. So my machine is ready. Now my machine is ready. Now I have got one Ubuntu machine. Now I have to connect this Ubuntu machine. So there are multiple ways are there. So one is like you can directly connect through the EC2 connect instance connect. So this is a direct way is provided by the AWS. Or if you want to connect from your local Git bash, so what you can do, you can open your Git bash tool. Okay. I'm showing this way also. So you have to take it here SSH client. Okay. So you copied here. So here is this PAN file. Okay. This is the public key file is there. Okay. When you are using PuTTY, so you need PPK file. So PAN file we need to convert into PPK by using the PuTTY manager. PuTTYgen. So PuTTYgen is converting your PAN file to PPK file. Okay, I will tell in the later session of this how to convert, how to do. Just we are going to access it through Git bash that I'm going to tell. Okay, there are different ways to connect, right? Either you can use PuTTY or you can use Git bash. So Git bash is a tool to access your any Linux environment. Like you want to use a Linux environment in your Windows, or you can use PowerShell. PowerShell is also provided by default. But this Git bash you need to install. Okay, so this Git bash will come when you are installing the Git, right, in your local machine. So Git bash will come. Okay, so first I go to my download folder because this PAM file is in my download folder.
Sir, putty application will also work the same as Git bash.
Putty is different, Git bash is different. Git bash is like a PAM file uses, and putty uses PPK file. Okay. So you have to convert this PAM file to the PPK file. Then only you can use with the putty. So if I search my see, this file is there, right, in my download folder. So because I'm not giving the complete path, I'm giving the same directory. You can understand this, right? So when I do this, I copy this SSH command, paste here, and I will say yes, but your machine should be running first. Okay? Now I'm in my Ubuntu machine. Okay, so here I do ls. It is empty. It's a new system. It's a new. Okay, it's a new. Nothing is there. Okay, so now my Ubuntu machine is ready, and I'm logged in my Ubuntu machine. Okay, that is the one way. Second is like you don't have this Git bash. So what you can do, directly go here and connect. So it will give the one terminal. Okay. So if I create any directory here, so I will see here. Okay, because both are connected to the same machine. So either you can use this, or you can use this, or you can use putty, or you can use Mova Scrum. There are many ways are there. See, both are same. It's a machine, right? It's a Ubuntu. Both are Ubuntu. Just I'm showing okay, if my local machine is not ready, but Ubuntu in the AWS will always be there, right? Okay, it is chargeable, but it is always ready, right? Okay, I don't need to rely on my local. Then we go to the, but it is chargeable, right? So if you think for the long run, right, you have to do more practice, right? So you can't keep it your this Ubuntu running, keep running, right? So you always set up the local Ubuntu, okay? And that one, like some VMs also you can use. Like I have one VM where all the softwares are installed. But I suggest we should install manually everything, and we should know how the installation is done. Okay. So when I want to installation, so simply I have to search Hadoop installation on Ubuntu. So this link is there, Phoenix NAP. Okay. In this link, so first of all, we need Java. Okay. We need Java. So I will be going to install. So I will use only one. Okay. I will. So installation wise, nothing different. First we do the sudo apt update we do. So sometimes the packages are not updated. You can use shift insert also the command. Whatever command you copy paste, you can do sudo apt. Okay, so first of all, you run this sudo apt update command whenever you start your first time Ubuntu. So you do the sudo apt update. Okay. See, now it's okay. So the packages were not there initially. So you need to install the package by sudo apt update, and then you have to install the JDK. So Java is needed because without Java you cannot do anything in the Hadoop. Hadoop is completely like on the based on the Java. Okay. So this is now you check the Java version. So my Java version is 1.8. Next thing is I have to install the SSH. This SSH is the like you don't need to do every time the passwordless, right? I'm making it Hadoop is having the 5 services, so it will not ask you the password to enter anymore. So we use the OpenSSH server and OpenSSH client. Okay? Directly I'm doing in the my home user. Okay, so I'm in the home path. I'm doing this installation. Okay? I'm not creating. So this step you don't need to do. I don't need to create a user separately because I want to keep it all my Hadoop ecosystem component in my home path. Okay, so I'm installing there. So I'm not going to create any new user. Okay, so now I have to make it enable passwordless SSH authentication. Okay, so I'm just this is a common step. It is not related to Hadoop at all. Okay, this is general we do. Okay, this SSH key general. Okay, this one. Next is authorize key. We have to copy the keys in the SSH authorize key. Next is we have to give the permission. Yeah, we can do virtual machine. Same steps you have to do. It is just you assume it like this is the your virtual box Ubuntu. Okay. So first you have to only thing is you have to download virtual box. Then you have to install virtual box. In the virtual box, you have to create a Ubuntu machine. So here you have to create a new new Ubuntu machine ISO image. You have to give the ISO path. That way you can do the setup. Okay. Once your Ubuntu comes, then you can go inside the Ubuntu and then you can do the same setup. Okay, it's the same. Okay, so this is done. So I will check the localhost. Right? And this is my connected. Okay. So next step is download the Hadoop zip. Okay. The main Hadoop installation folder we need to download. So this is the official website page. Okay. We go to the official website page. So this is the current version 3.3.6. This is 2023 June 23 is released. So we need a binary. So we go to the binary. And this link we can copy and we can use wget command. Okay, how to download in the or we can download in our local and we can copy it to the our virtual machine. So there is a WinSAP is there. So WinSAP is something you want to copy from your local machine to virtual machine, your Ubuntu in the AWS. So you have to use WinSAP. Okay, so in the WinSAP you have to connect here your host name, your public IP, and then you can use here in advanced, you can use the PPK file. Okay, so you have to use authentication, then only it will allow to copy. Okay, that I will show later. Okay, so that is the way like something is you have locally. If you download here in Windows and you want to copy, but instead of that, I can directly go here and wget IP, wget, and I can paste this. The wget command can download anything. I have to extract this star file. So this is the same thing they are doing. They are wget command. So they are downloading the star file and then they are using tar xdf command to extract. But here I have to change the version. So whatever version they use, our version is different. Okay, so can I see here Alice? Here is a T jar that file is coming here. Yes, sir. So here is, I will use the CF. I have to change the version here because my version is 3.3.6. Oh, well, let's, this Hadoop 3.3.6 is installed. So I can remove this other one, tz file, unnecessary to take the space. So now in this one, Hadoop, I will go inside this. So here is my this installation folders, right? All these are the folders in the my Hadoop installation folder, right? All this bin and lib, everything is there. Okay. So next thing is what I need to do. Once this is done, now these are the configuration file I need to change. This is the only step left. Once this is done, your Hadoop is ready to work. Okay. So we have to open the bash RC. Bash RC is like environment file where all the configuration detail you can keep it. So that will be used by the entire Ubuntu. Okay. So first is we will be modifying the this bash RC. Once this bash RC done, then we will modify this file, this file. So I told you this file, hdfs side, right? But there are the other files also there. The common configuration of the Hadoop will be stored in the core side. If it is a related to Hadoop file system, it will be in this file. If it is a related to mapreduce side.xml, mapreduce related, or yarn related, yarn side. Okay. But common configuration, which is used entire Hadoop file system, that will be used in the core side. So these files we have to do some configuration we have to. Okay. So that we will do. But first, before that, we add in the nano bash RC. So here is a one change. I do the change here. So okay. So first is what is my location? What is my this location? PWD. This is my location. Home Ubuntu. So here my username is a Ubuntu. Okay, but if you are installing in the virtual box, this Ubuntu will not come. There will come home/your username. Because your username will be, there will be your username will be your Ubuntu, and there will be Hadoop will be installed. Okay, so your username will be. So what we need to change in this one, as per this one, we have home Ubuntu and 3.3.6, and other remaining things will be same. Only thing is here you have to make it equal sign. Okay, and this thing you can copy and you can copy paste in the nano bash RC. Bash RC the file. So this bash RC you will not get here. You will get it in the home folder here, PW. In this folder you will get the bash RC. So if you try anywhere bash RC, you will get empty file. Okay, so be aware. So when you are opening this bash RC file, go at the end. Here, put this entry, whatever you change. Okay, but make sure your entry should have proper username, right? This username and this equal sign and this proper word. Okay, so I save it. Control X. How to save this nano? Control X, Shift Y, Enter. You can use VI editor, VI, VASHRC. This is a VI editor. You can open in the VI editor. Okay, and then :WQ you can do. Okay, so you have to do escape :Q. Right now I have no changes. So :Q exclamation. So my file is saved, but this file is not in effect if I don't use this command source BASHRC. The source command I have to use whenever I do any change in the bash RC. So always use the source command. So if you see here, after that they use source command. Either you use tilde/ this one, or you use like in the home directory. If you are there, always use in the then .bashrc you can access. But if you are using somewhere else, you are using, this is denoting this tilde sign, your home directory. So if you are in some other directory, you are there and you want to open, then you can use tilde sign. the tilde sign you use, then it will open your gradual. Now, next file is this Hadoop env.sh file. So already we set the Hadoop home path, right? We set Hadoop home. Now I can access my this Hadoop env.sh. I can access my Hadoop env.sh. This is my Hadoop env.sh. I will add here Java home path. So my Java home path is this Java underscore home. So by default location of the Java home is user live JVM JDK this AMD64. So copy this and add in this file. Okay, so you can add anywhere because it's export. So you can add Java home and Control X, Shift Y, enter because this is a nano editor. So you have copy pasted this one. This is done. Now next is this is just showing you where is the Java, right? Okay, so we don't need to do anything in this. So here is a next file is a CoreSite.xml. Copy this. We can open CoreSite.xml. So CoreSite.xml will be empty because it's a new configuration, so nothing will be there. So we have to add the configuration in the middle of this configuration file. So what I need to change, I have to copy this configuration. So I take it part of the configuration, but I need to modify this. So what change I have to do this? I have to change first my user. My user here Ubuntu, home Ubuntu. Okay, and I want to create some temp directory. So it is fine, whatever name is there. And this is a local host, 9000 is the default port for the Hadoop. So I copy this property and then I will paste it in between the configuration tab. Okay, like this. And then I will save it, Control X, Shift Y, enter. This is the one file I change. Second file I will change hdfs site.xml. hdfs site.xml. In the hdfs site.xml, same thing I have to do. I have to copy the another configuration. So if I go down, this is the hdfs site configuration. This hdfs site configuration. I will modify it. Only these two I have to modify, CoreSite and hdfs, because these two are using your location. So here is the location is Ubuntu. So my home directory. This is I'm going to create my user directory, this directory. So one directory is created for the name node. So it is a single node machine, right? I'm not using any cluster. So my name node and data node on the different machine. So here is both are in the same machine. So name node and data node both are in the same machine. And data replication factor is 1. If you make it this 3, it will be used for 3 for entire system. Okay. So I was talking about this one. So if it is 1, because why it is 1? Because it is a single machine. There is no point to keep it 3 or 5 because you don't have number of nodes, right? So you have only one machine. So that is the reason we kept it 1. But if it is a cluster, then it will be either 3 or 5 or depend on the configuration. So now I will be copying between the configuration. Okay, then make sure like your property and property is ending properly /property. Control X, Shift Y, enter. Now next is a mapreduce site.xml. So next file is mapreduce site.xml. MAPRED. Okay, this file is also I need to add, but now I don't need to do any change. Just as it is, I copy paste. It's property, copy paste it here. Okay, and Control X, Shift Y, enter. And now my last file is yarn site.xml. The yarn site file also as it is copy pasted. So it is talking about yarn is I talked about the yarn, right? Resource manager, those properties are the yarn site.xml. So these are the total 5 XMLs we have to modify. I open yarn site.xml. So if you have installed this Hadoop on your virtual box, you can manually change it. Like you can go to the directory and open the file and copy paste it. That is more easier. But here is there is no hardware, right? No, we have virtual machine there. This Ubuntu, right? So we have to do through command line. So this one I added, Control X, shift Y, enter. Now the next thing is we have to format the name. This command we have to use and format the name node. So this is, we are going to format our name node. If every steps you have done properly, so now your Hadoop is installed. Now you can start -all.sh. So you will see 5 services will start one by one. So 3 services are the storage services, name node service, data node service, and secondary name node. And the 2 services are the processing services, resource manager, and node manager. So after this, you can run any Hadoop command. So it is done. Now, if I do ls, this is showing me the Linux command. But when I do hadoop fs -ls / it is showing me the root directory. But right now, nothing is there because my Hadoop file system directory is empty because it's a new formatted, right? So when you format it, nothing is there, right? It is completely empty. There is no data, right? Okay, now I want to create some directory over there. hdfs dfs. I'm showing hdfs dfs -mkdir, and I want to create a directory with the name test in the root /test. Now I will do ls / I will see here test. So one directory came here. So it's also a file system, right? Same Linux command I'm using. Same like whatever the ls command comes, right? So in the Unix, right? Linux, right? So same thing is coming here. It is a directory showing. This is the user permission, group permission, and other permission, right? You know about this RWX. And this is, I mean, right now there is, okay, this is a user and group. Okay, if any replication factor is there, it will be coming here. Okay, so this is a directory. That is the reason it is coming hyphen. Suppose you create some file here. Now, if I want to create a file inside a directory, I have to use the touch command. Okay, when you do hadoop fs, you will see all the Hadoop command file system. Okay, when you do hadoop fs, so these are the list of command you can use. These are the list of command you can use: hadoop fs, ls, chmod, cp, du, find command, get command. You can use all these commands. Head command is for getting the top lines of the file. Tail command is the last lines of the file. Okay, there is a touch command is there. So touch command you have to use, but touch command will create an empty file. Okay, so when you want to do hadoop fs -touch, and then you say every command you should have to start with hadoop. So hadoop fs -touch, then you say test is a directory, and there you want to create a file name is test1.txt. And now you do hadoop fs -ls /test you have to do, because this test1.txt is inside the test. If you do only /, so you will see what are the contents are there inside the test. Okay, so you have to do /test. So you will see here. Now you can see this changed to 1. Because why is 1? Because your application factor is a 1 in your XML. Now every file will be with the one replication file, one block. Okay, so one replication factor is there. Okay, and if you are giving 3 replication factor, 3 copy, but it's a same machine, so there is no use of more than one replication factor. So this is a file, but this is a 0 size file. If you see the content of this file, hadoop fs -cat, and you say test1.txt. So nothing is there, right? Because it's an empty file. So now if I create some local file here, cat my txt, I'm creating a new file here locally, and this file control, I saved it. Now ls I do my local. If I do ll, I will come to know this is my txt. So this is a file, right? And this is the which user? Ubuntu, because Ubuntu is a home user. So whatever file you create, it will be creating by the Ubuntu. It's a Linux concept. When I want to copy this file in the Hadoop file system, I have to use hadoop fs minus put command. Or we have another command is copy from local. So you have to see here the list of commands. So here is a copy from local. Local is there. This is the copy from local, and minus put is there. Minus put is there. So when you do copy from local and give the local file, what is your local file? My.txt. And what is the Hadoop path? The Hadoop path is test/test. So here I want to copy this my.txt file. When I do this, okay, the file is copied. Now, if you do hadoop fs minus ls test, you will see this file here. So this file is a 19 KB, right, to get the file. And now you want to see the content, hadoop fs minus cat. Then you get test/my.txt. Extension is not necessary, like you can give the extension or but it's a case sensitive. Okay, so whatever you give, it should be very, very case sensitive. So you should use the my.txt so you can see the content. So these are the very basics command, like how to install Hadoop and then how to run command. So there are the different commands are there. Okay, let me show this append to file. So cat command we seen so far. What are the commands we see? We have seen. Okay, Hadoop fs minus ls Hadoop fs minus mkdir. You have to create some directory in the root. Hadoop fs minus cat. Some directory we have the file /test/my.txt file. So these are the commands. Okay, suppose I have a two file. I say one is a cat my.txt. Okay, another file I'm creating cat my.txt. Okay, so I have a two file my.txt. Both files content is there. Okay, now my requirement is I want to merge these two files and create a new file in Hadoop file system with the data of these two. There is a command hadoop fs minus append to file. Then first file is my.txt. Second file is a my.txt one. You can have more than one, two also. Okay, you can give. But when you talk about the Hadoop path, then you have to give complete. You have to give test/ I say my.txt is already there, so I have to give my.txt2. Yes, from a new name I'm giving. Okay. Now I want to verify it content of my.txt2. So Hadoop fs minus cat /test/my.txt. You will see both lines will be there. It's combined. Okay. So this is basically append to file. So there are the other commands. Fs I do. So here is we have seen this append to file. Cat is there. Checksum is for the like whether the two files are the same or not. We can have a checksum. We can check. Okay. So we have three commands which is related to permission. We know about permission chmod, chon, chgroup. So if you want to change the permission, chmod is there. If you want to change the group, chgroup is there, and chon for the owner. Owner is the person who created the file. You want to change the owner. So there is a octal permissions, you know about the 777, right? Or 754, 666, right? So this octal code you have to give. Okay. And -r is used for recursive. Suppose you have a file inside the directory, you want to apply all the file inside the directory, recursive, you can use -. So when I say I want to change right now, what is the permission of my Hadoop fs minus ls? I do test/my.txt2. My.txt2. So there is a read permission is there. In the user is a read write, but here is a read and read. Group is a read only read, and other is a only read. write and execute permission is not there. Okay, in the group and other. Okay. So ch mode, hadoop fs minus ch mode. So always we use hadoop fs. And this is the 7.7 is for all read, write, execute, read, write, execute, but we can give other also 7.5.4. So there is a, these numbers are significant number is there. Like 7 means like for read, write, and execute. So 3 is given for read, and like a 2 and plus 1, like that is a combination. Okay. So I mean, just now I'm going to show you 777. I want to change for, I have to give complete for. Let's test. So I have changed the permission for the all read, write, execute, read, write, execute. This is the ch mode, and ch group, like this group I want to change. I say I want to change to Hadoop group, or I want to change the honor. This one. So I can use ch on command. Yeah. So some other command is like, suppose I have a 2 directories in the Hadoop file system. I say I have another directory. I mean, in KDI. I'm creating a /test slash. Okay. In this directory, I want to copy a file. Hadoop to Hadoop, I want to copy. So there are 2 commands, cut copy or copy paste. So CP or NV, 2 commands are there. When local to Hadoop you want to do, either you will use copy from local or put command. When you want Hadoop to local, you will use either get command or copy to local. Copy from local and copy to local. There are 2 commands are there. So copy to local means you are copying the file from Hadoop to local. Okay. So when I say here I want to do copy Hadoop to Hadoop, so I will use Hadoop fs minus cp. Okay. My file is there in the test slash my.txt2. This file I want to copy in another Hadoop directory test slash new. Okay. So when I do this Hadoop, I change. So this will copy the file. Now I want to verify it. Hadoop fs minus ls test slash new. It will copy the file. So this is all are the basic command, like you can do practice with the. Okay, so if you want to see what is a Hadoop fs minus uses command. The uses command is like for any command you can see the uses. Okay, like suppose I want to see the uses for the cp command. So it will be telling about the what are the uses, means options are there. Okay, can you see here one option is -f. So if I'm doing the local copy, when I say Hadoop fs minus put command or copy from local command, right? Copy from local this. If I run this command again, what will happen? Because I have already copied once, right? So when I second time enter this one, it will be saying file exists because already file is copied. So it is giving a warning, not warning, error. Blindly you cannot copy the file. Okay. So but forcefully I want to do, so what should I do? So forcefully you want to do Hadoop fs copy from local minus f. If you use this option, it will copy the forcefully. So whatever your local change is there, it will override your Hadoop file system. Okay. So anything you want to copy in the Hadoop file system, okay, so you can use the Hadoop fs copy from local minus f. So this minus f option you can use either put command or you can use a cp command you can use, but not for MB. Okay. If I try with MB, okay, I say Hadoop fs MB. I want to move any file from any one directory. Okay, I say test slash test1.txt. Okay, this one I want to move to the my test slash new directory. Okay. So when I move means it will be cut paste. So if I go and search ls, and I will see my where my test1.txt test folder. So it will not be there. It is moved to the new. If I check here Hadoop fs minus actually. Test1.txt will be here. Okay. And one way is when you use -r option, the advantage of using -r means recursively also you can see list. We know, right? Recursively means it is apply anywhere. Either you can remove the file or copy the file. You can do anything with the -r option. But when you use -r option with the ls, so you don't need to go check each and every directory. It will show every directory. If you see the difference here, if you do only ls, so you will see the directory level, you see only test what is there. Okay. But if you want to see inside the test any directory new is there, so you can see in one single command -r. So -r is a recursive, right? And you can use this -r anywhere. Either you can use with ls, cp, put command, copy from local, so it will work. Okay. So that we can do. Okay, so we can check other command, uses command I told. What is the truncate command? Truncate command is like I want to cut some character in my file. Okay, so I use truncate command. So hadoop fs truncate, and then I say I want to cut the 3 character. Okay, I say I want to. So from the beginning, it will take the character and rest it will cut. Okay, so I say the file test slash new slash txt cool. So it will modifying the file itself. So it is very careful, right? Whenever you are using truncate command, it will original file will be modified. Your original file will be modified. Okay. Now I see hadoop fs minus cat test slash new slash my txt. See, this HEL is coming. Okay, this HEL. The 3 character it got. Okay, this HEL. These 3 characters are coming because you did 3. If you do again on the same file, now you say 1, so only H will be there. It will be original file, it will be not. It is truncated. Now you see fs minus cat. So only H you will see. Only H is there. Okay, so this one is like command. Some commands are there. RM command, RMDIR command, right? Removing the file. Okay, setrep command we see. How to change the replication factor. How to change the replication factor. So we right now the replication factor for the test1.mytxt2 is a 1. So I want to change hadoop fs minus setrep, and I want to change the replication factor for 3. So I give 2. Whatever application factor you want to change, and I say file path. Application 3 is set. Now I want to verify it. I will do ls command. You will see here the application factor is changed to 3. So now it will maintain the 3 block of copy. Okay. So manually you can change the application factor for a file using the setrep command. Okay, so you can use tail command, like add and tail. These are command like we use to get the top data, or tail means like generally the log files one tail command we use. Okay, so I have for this testing I have to perform from log. So I will show you how the tail will be keep appending the data. Okay, so here I will open any one file in the tail. Okay, suppose I say I'm opening this file test slash minus f option. Then I say test slash new slash my txt2. Abhi right now only one character is there, right? H is there, right? But it is keep waiting for the more data, right? How the more data will come? So we have open already another terminal, right? So here we will put the data, right? So I will use append to file to copy the data. Hadoop fs main files name. And so this data is just testing purpose I'm doing, but you will getting a data from anywhere, okay? Because your logs is getting data from any server, right? So just for testing purpose, we are sending the data. Okay, and what is the file where we have to get to the data? This is the file. Our test/new/my txt2. File is already there. It will give the error. I will use -1. Here it is successfully done, right? Now let's see our another terminal. Can you see here the message came, right? So this is keep adding. So again and again, if I send now, of my txt2. Yeah, depend on the memory, right? Okay, because if you give the virtual box your good configuration RAM in the virtual box Ubuntu, so you depend. Because I took it here 16 GB RAM virtual machine, right? Ubuntu, right? So this will all depend on if you use micro instance, right? 1 GB RAM one, so it will be slow. So it will keep appending the whenever the like you will be this tail command. Okay. So tail command is in here. Yeah, this kind thing, right? See. Okay, so if you run 25. So this way we can use tail command. Okay, the tail command is like when your content keep appending, so you can use the tail command. So you can do more practice on this mkdir. These are the suppose you want to create multiple directory together. So what is the option? Hadoop fs minus mkdir. Like suppose I want to create a test directory for the two C directories I want to create, test1, test2, test3. If I do right now, it will give the error because this directory is test1, test is there, but test1, test2 is not there, right? So it cannot create the test3. So there is an option -p you can use. That could be usefully you can use. So it will create all the directories, any number of directories. So these are the commands, like you can use some more commands are remove command, okay, rmdir and rm command. So if you want to remove any particular file, rm, okay, so you can give the location. So same command you use in the, okay, so deleted, so you can use in Hadoop, but entire directory you want to delete, rmr you use, it, rmr, and here you have to give the directory path. So if I say here another directory, delete the test, so delete the test, and this is deleted. Now if I do Hadoop fs minus ls/test, it will say not a file or directory because everything is deleted by RMR. Okay, but there is a way, right? Like, okay, because there is a trash, so there is a one default trash is there, but we need to configure that trash, and we can get back our data from the trash. So if you want to remove permanently from the trash, there is a expunge command is there. If you see here, there is a expunge command. Expunge command is like whenever anything is in the trash, that will be permanently deleted. Okay, so you can use that one. So this trash directory is created in the user directory. Like whatever your directory is there, so there is a one user directory created, but we have to configure the trash. So configure trash in Hadoop file system. There is a one property we have to set it in the hdfs style.xml. I didn't give that property. This is the property. So in the core site.xml, you have to add this property. This property and some time interval you have to set. So you can give some time interval, hours, right? Like 24 hours, like this. Set the value of the this in the server core site.xml 44. So you can site.xml. For this, we have to restart our project. Control X. Because any change in the configuration we do, we have to restart that. To stop -all.sh. Then you will see one user directory will create, there will be one trash directory create. So whatever you delete, it will go to the trash, and then you can recover by using the cp command. The cp we know Hadoop to Hadoop copy, right? We can use cp. So cp command we use to copy from the trash directory to original location. Okay, so when you do start, so it is starting all the 5 services. how many ways we can access the Hadoop file system? One is this command line. Another one is using the programmatic way we can do. The programmatic way is a REST tip, right? We have a Java program we can write and we can run the Java program. And the third way to access the Hadoop file system when your Hadoop file system is not locally there. So you can use curl command. So REST curl command we can use, right? REST curl command to access remote Hadoop file system. So there are the REST curl command. You can access any files, any application you can access, not only the Hadoop. So create and write a file. So curl -i export. So here you have to prepare a complete URL with the IP, host and port. Port is a 9000. Web hdfs is the API. They expose it and just give the command what operation you want to do. OP create means you want to create some file, or you want to append a file, or you want to read a file, right? op.open. If you want to create a directory, op equal to mkdir. Okay. So when you do this curl command, and then you will get the response in the JSON as a okay, 200 okay means your file or directory is created. Okay. Or you want to rename a file, you want to delete a file. So whatever you can do the command line terminal, the same thing you can do with the curl. But generally this is used when you have remote Hadoop file system. You cannot open the Hadoop file system locally. Then you will use the host and port, and you should be having permission, right? You should have the octal permission, right? You have a permission, right, to give your username, password also. Username, user. Okay, so we can see some command is there. So that one is here is a so this Json one has given some examples, right? So like name is user.name is this. So if that user has the permission on that remote file system, so he can access the get file system. So get file system is basically get file status. It will be give the list of file access. Okay. Another command create a directory. Someone is using like user.name is the user ID and then operation, right? Whatever the operation is. Okay. So this way we can access the remote file. So our Hadoop file system started. Okay. So now I just try to delete a file. So first I need to create a mini Hadoop. Yes. Copy some file. Now I delete this file. Hadoop So now this message is coming. Previously, this message was not coming because your trash was not configured. So where is this trash? Trash location is this. Because it is saying user Ubuntu dot trash and then current. So in your user folder, in your Hadoop, this is the Hadoop file system, right? hdfs colon / localhost 9000 and user folder one Ubuntu. If I see Hadoop fs -ls/I do. So now extra one more folder is created /user. Previously it was not there. Just now you see the date, right? So just see here 1517. So just now 1 minute before this user folder is created. If you go inside this user, so another folder is created inside that Ubuntu. That is your home directory, Ubuntu. So inside you go Ubuntu. Then you will see the trash. So if you go trash folder trash, so you will see another folder is current. So if you go to the current, so you will see your directory folder. So current has your directory and entire test/my.txt path is there. And now I will do Hadoop fs -cp command, and I say I'm in the current directory now, right? So I can say, I want to copy this entire test directory. Test, I say, I want to copy into my, okay, test is already there. So I will do give complete path. Okay, I have to give CP, I have to give this is my file. I want to get back this file. I will do CP command, and then I will say where I want the same location, like /test and my date. Even if you don't give the file name, it will copy with the same file name. Okay. But if you want to change file name, here you can change the different file name, or if you want to keep it same file name, you can give search. Now I will check my file is recovered. Hadoop fs minus cat. I say test slash my dates. So my file is recovered, right? So this way we can configure our trash, and this configuration we can do, and then we can get. Suppose this trash I want to delete this trash data, right? So there is a expunge command. Hadoop fs minus expunge. When I do this, it will not exactly remove the entire data. It will create another folder and keep it in the buffer. Okay, because you can still get, but yeah, so see here, created a trash checkpoint. So it has created a one directory with the date and timestamp folder. 2023, 2310. I think this is. So some folder ID is created, everything is kept it there. Okay, now I see Hadoop address 9 ls, and I check this trash directory. User. So only one directory is there. So everything is moved in this folder. Okay. So when you do expunge means it is whatever is there in the trash, it will combine together and keep it in a one directory. Okay? So that is the expunge story. Okay, so what other commands are there? So there are so many commands are there. You can practice. So Hadoop fs you do. So Hadoop fs help also you can. Hadoop fs minus help. And suppose I want to get the help of tail command. So this is the tail command help. You can get it. So what are the switches are there? What are the purpose of the command you will get? Okay, one more command is a stat command. So this is showing the date and time thing. That can say it's just showing the date and time, like the static system. That's it. When this file is created. So this kind of thing, like a touch command, uses command, stat command, this and rmdir command, put command, mv command, okay, mtdir command, ls command, help command, head command, okay. Find command also, right? Like if I want to find a particular pattern file, so I can use the find command. Hadoop fs minus find. I want to find something in the directory. Something to the find command. You have to give some pattern, right? Suppose I want to find through find command, I want to find something. It's simple. Okay, the general syntax is what is there. Okay, let's check the Linux system. Okay, so Linux family. Same thing we will do with the Hadoop. Hadoop is nothing different. Okay, just only Hadoop access here to do. Okay, this is the syntax. Find. We have a path. Okay, we have the path and we have the minus name and the name. Okay, we have a path and minus name and file name. Okay? Same thing I do. Path means you want to do in the current directory, which directory you want to do. So you give the complete path. So you have a path slash test directory. And minus name, I say I want to find file name is my.txt. My.txt. Regular expression also you can do. See, this is fun. So I told here slash test. Okay, because my Hadoop directory I have to give. Okay, because I'm not using find for the here local. I'm using the find here for the my Hadoop directory. So I can give the Hadoop directory. Find command I can give. Okay, is it clear? So I'll take a break. Okay, and okay, so then we'll connect and I'll show the mapreduce because this is all Hadoop. Anyone has any question can ask me. Any command related to anything? Okay, one command is get merge, very important command actually I forgot. So we use the append to file, right? We use append to file. But suppose I want to get the two file from my Hadoop file system and get the one merged file. Okay, so if I have a two file in my Hadoop file system, so I'm putting another file. txt1 is already there. In the test directory, I have put it. Now I have a two file in my Hadoop file system. So I will do get merge. And then I say slash test slash my.txt. That is the first file. And slash txt test slash my.txt1. Okay, and these two files I want to combine. I want to get in my local, I say file name is my.txt2. That is nonsense. When I do cat, simple cat I do because it's my local file system. ls and cat I say my.txt. So I'm getting the file, which is the combination of my.txt. If you see the content of my.txt1, we have to check Hadoop one because we copied from the Hadoop. So Hadoop fs means cat slash only one line. When I see my.txt to Hadoop file system, my.txt. So both have one line. So one line is there. One line is there. Is hello, I'm fine. Hello, how are you? The same thing is coming. Which file you will give first, the content of that file will come. Okay. So if you are giving the text one file first, txt file, so text one will come first. Okay, these are all the commands. Okay, and the 10-minute break I will do this mapreduce. Instead of the Hadoop fs, we can use. Yeah, we can use hdfs. So all this command, whatever we use, if I write hdfs, it will work. hdfs. Just only same thing will come. Do we need to use Java language to learn Hadoop? See, Java language we don't need to learn, but Java language knowledge should be there because when we are writing some of the things like UDF in the Hive and when we are writing a MapReduce code, right? So that we need a Java. Okay, so nobody's asking to write a Java program from the anyone because nobody using the MapReduce. But we should have a basic core knowledge of the Java, right? Okay. Because any programming knowledge is better to know, right? Because when we are learning Python, Scala, any language, because Scala is completely inherited from the Java. So when we are learning Scala for the Scala, Spark Scala, so then we need like a Scala, and Scala is completely inherited from the Java. Okay. So basic fundamentals like loop, function, variable, right? How to define. So any tutorial point Java, you can go through tutorial point Java. So you can go through any. So Java is not must, but basic fundamentals of the any programming language, you know, then you can understand the code of Java. Tutorial point. This is the Java tutorial of the basic this all syntax thing like class, object. So we don't need go in much on the OOPS concept, object oriented concept, just basic fundamental like any main program is there. So we are writing some loop function variable, right? Operators, right? Okay, let me connect in 10 minutes. Okay, you guys are getting my voice? Hello? You guys getting my voice?
Yes, Arvind. Yeah.
Yes, yes, yes.
Okay. So next thing is my mapreduce. Okay, I just start first basic because I cannot run now, but tomorrow I will show the mapreduce program how to execute. Okay. So let's quickly understand what is the mapreduce framework. Okay. So mapreduce is the base for the entire Hadoop architecture because every component internally is using MapReduce. So there is a one way we can write our own custom MapReduce code, okay? Or if you are using Hive, Scoop, HBase, all this internally is converted into the MapReduce, okay? So in the other component, we don't need to worry, right? Because it is done by the Hadoop, right? But when I'm using my custom MapReduce, so I have to write my own custom MapReduce code. Okay. So first of all, like what is the traditional approach of the computation, right? Processing approach. So if I say I have 5 different machines, okay? I have 5 different machines and I have a data there, 5 different machines. I have some files data or some files having the data, okay? So if I want to do some searching things, I want to do word count, okay? Just typically we take the word count program, okay? So this word count is nothing but in this particular these files, we have the words and I want to get the total word count from all the files. Okay. But if I'm saying the traditional approach when we don't have the Hadoop, right? So what I need to do, I have a writer some program like Java program or Python program. I can do file by file and machine by machine. Each machine, how many files are there, I can do, okay, in one machine. So one machine, one file, I have found the word count, okay, and the second machine, second file there, okay, I have done the word count, okay, and finally I will aggregate my all word count, aggregate word count, okay. This is like a manual okay, manual approach. And when I'm talking about when I'm not using any distributed system, right? So when I'm talking about the Hadoop, right? So Hadoop is a distributed system, right? It is using a cluster and cluster has the node and nodes are processing the data, okay? So all these things like what we were doing our individual machine, that is done by the completely Hadoop MapReduce, okay? And the Spark is also following the similar approach, okay? The only difference is Spark is providing in-memory computation. It's more faster than the MapReduce and we don't need to write a huge amount of code. So here we are writing a Java classes in the MapReduce, okay? So we have a one entry point class that is called driver. The driver is a class where my execution will start. I will show you the code. The driver is having a main class. We know that any Java class has the main function and main function is the starting point of your program. Starting point of your program. Suppose you have written a hello world. You have seen hello world, you are writing in the main function. I showed you the like some Java program, right? Any website, you see the tutorial point here. So you are writing if you say the main function, this one has the hello world. So when your program will start, it will start from the main function and main function will start your execution. Okay. So when I say the driver is a class, one driver class I'm writing in the MapReduce, and this driver class has the main function. So some other classes also we need. One is a mapper class and one is a reducer class. Okay. So in the MapReduce program, in the MapReduce, we have the different phases are there. The first phase is when I say map phase. Map is basically splitting the data into various machines. Okay? So that parallel processing can happen. And what we will do in this map function, each word we will give the one count. Okay. Suppose I have 100 words are there. Okay. So I will give each word, even the word is repeated, but I will give each word as a one count. Okay. Suppose my one word is a hello, comma one. Another word is a how, comma one. So just take one example. I have a one test file, test.txt file, and it has some data. Hello, how are you? Hello, how are you? Okay, this is my data, and I say I'm fine. And this data is the space separated data. When I apply the map function, so map function what it will do, it will, this particular line will go to the one mapper machine, one machine. Okay, just assuming it, if this line of text data, if it is depending on the block size, now the block size comes in picture here. I'm assuming it like this block size is the suppose 128 MB. So this entire data will go to one block. Okay. And this second line will go to the another mapper machine, to process. Mapper machine means the number of nodes are different nodes going to process, because in same machine, it will not be a parallel processing. I'm sending the data in the different machines so that the data can be parallelly processed. So this all data will be going to the separate machine by using this map function. What is doing? Here is the map function is applying. Every machine it's having the code. This MapReduce code is shipped. This MapReduce code is shipped on each machine. And what will happen practically? The map function will have the logic like we are separating each word is a one count. First, we are splitting the word. Right? How we will split? By space. We know that this is a, I will show the code, then you will understand more clear. So just you understand here, like this, each word will be separated out by the space and give the each word is a one count. How many words are there in this line? 4. So hello, comma 1, how, comma 1, r, comma 1, and u, comma 1. Right? The same thing will be in the second mapper, right? So this same thing will be here also. Okay, and here is the only keyword is there. So here map function will be doing I is comma 1 and m comma 1 and find comma 1. Okay, so this way the words are splitted and each word is given one count. The next phase is the shuffle and sort phase. Shuffle and sort. Okay, so what this phase will do, from the different mapper machine, now the data will be keep aggregating for the same thing. So hello is coming in these two machines. It will go to the, I suppose 5 machines are connected in the network. Please consider as a node. Yeah, 5 machines is considered as a node. Okay. So all machine will be the node, right? So here I cannot say all 5 machines will be used at a time, because if my data is too small, I can say I'm saying, okay, this 3 lines of text, 3 machines is going. But maybe the case, right? Like out of 5 machines, my cluster could be so much large. I can't know. Okay, it could be a 10 node, 20 node, 30 node, but I cannot say how many nodes Hadoop is using. We cannot know. It is decided by the Hadoop. Okay. So first it will distribute my text file, this test.txt data, it will distribute into the number of nodes depending on the block size. And what Hadoop will do, MapReduce will do, not Hadoop, MapReduce, what it will do, MapReduce framework, it will ship the complete MapReduce code to each machine. And first is the map function. So actually there is a sequence of the program. The driver is calling mapper class, map function. And then control goes to the reducer class, reduce function. This is the sequence. And once the reduce function is called done, then it will come back to the driver, because driver is the starting point and driver is the ending. So I will show you the code, you will clearly understand. when the program starts from the driver, it will go to the mapper class map function, then reducer class reduce function, and then come back to the driver. So, but in the mapper and reducer, there is a one more part is there, that is a shuffle and sort. Okay. So that is, there is no class for that. There is no class for that, but this is internally done by the mapreduce. There is no class for that. Only code we are writing for 3 classes: driver class code we have, mapper class code we have, and reducer class code we have. Okay. But internally shuffle and sort will be work. So what shuffle and sort will do, it will find the same key and group together 1, 1, and it will find how 1, 1. So different machines, it is bringing the data together. It is not completely aggregating, just shuffling and sorting also apply. So sorting, what it will do, who will come with the sorting? AR will come or AM will come? AM will come first. So AM, 1, AR, 1, ARE, 1. Okay, this will come. So this will be a sorting order, will keep it. Okay, and I will come, I, 1, and then hello, 1. So that is coming. Hello, 1, 1. How 1, 1? Actually, R is 2 times. So 1, 1. How many number of time occurrences are there? M is 1. Okay, R is 1, 1. I is only 1. Hello is 1, 1. How is 1, 1. And U is 2 times. So U, 1, 1. Yeah. So like this, data is shuffle and sorted. Okay, U, 1, 1. And finally, the reduce space, what it will do, it will making it the sum of the values. So M, 1, there is only 1. R, 2, that is I, 1. Hello, 2. Hello, 2. How, 2, and U, 2. So this is my final word count. It will be written to the my another new file is test underscore output.txt. So this all things I will define in my driver. What my input file is there, what is my input format is there, what is my output file is there, what is my output format is there. So that I will decide in the. So what is typically MapReduce code is, this is a Java code, src main Java. Okay, so here is my classes are there. So I show you word count, mapper, reducer, and this is my driver. Okay, so these are the 3 classes. Okay, so driver is the main class. In this main class, if you see here, I have a map function. So map function, what I'm doing is I'm splitting the word like space. It is using the tokenizer. So I'm giving each word is a 1 count. I'm giving word, 1. So context is the object which is common object between the mapper. How mapper and reducer can communicate to each other. How mapper will come to know what data is there. How reducer will come to know what data is mapper has written. So context, whenever mapper is writing in the context, the reducer will be taking it from the context. Shuffle and sort is taking from the context, and then whatever shuffle and sort change will do, that will be read by the reducer context. So every mapper reducer have the context object, and this context they are writing, and next component is reading from the context. So context is a common object where we are writing is the word, 1. So mapper task is to just write the data, each word as a 1 count. Okay, but when we come to the reducer what is doing? Reducer is first getting the data, value.get. It is getting the data and doing increment plus. Okay, so initially I am assuming it my sum is 0. So if I have a 1, 1, how much will be the sum? 2. If I have a 1, 1, 3 times, so it will become 2. So like this, it will add values, and finally it will write again in the context. And this is the final result, because after reducer, I will get my final output data. Okay. So in my driver class, I will be creating a job object, because I have to create as a job. And I will create a job, I will set a mapper class, I will set a reducer class. This is another class, combiner. Okay. So combiner is used for the performance purpose, but we are just talking about here mapper and reducer. And what is my output key class? So here in the MapReduce, we have format type is a text type, like it's a serializable type, because Java type is like when we are doing any work in any system, that is fine. But my data is traveling over the network. In that case, I have data as a serializable type, and serializable type is a text type and int writable type. So every Java type is corresponding there. There is a serializable type is there, writable type, int writable, long writable, double writable. Okay. So value means it's a number, and text is a key, that is a string. Okay. So I'm just using this output key class and output value class, and the driver I'm just setting the mapper class and the reducer class. And finally here when I'm doing system.exit, so it is just waiting for the completion of the mapper and reducer. So once mapper and reducer are completed, then finally I will exit from the driver. And here one more thing I'm setting also in my driver, input format type and output format type. The default input format and output format is a text type, because this is a text file data. But sometimes if I am reading data from the database or writing data from the database, so DB input format is there. So there are many input format and output format type is there. So corresponding one input format type, there is a one output format type is there. Okay. So this is a typical word count program. So we can run the program two ways. For testing purpose, we can run in our local IntelliJ, we can run here. Okay. Or another one is we can run in our cluster. So finally, like when our testing is done locally, we can run in the cluster. Cluster means in my Hadoop node, like here. So I will be running my program here. So I will have the application here, right? So I have to, so here I cannot do any modification thing because this is a command line tool, right? So first we do testing in the local editor in our IntelliJ. And once our testing is done, then we will commit our code in the GitHub, right? So this is like a GitHub code. I will create a GitHub repository. I have just MapReduce word count. I have created a repository, and I will push the code from my local, and then I will do the git pull here. Okay. So my repository name is this one. This is my repository, this github.com. I mean, right now nothing is added in this. So I have to, if I want to use here, so right now here GitHub is not there, right? When I do git clone, see, I will get the error because this is the Ubuntu I have not done. Okay. So here, I think it is directly there. It's there already. By default, they are coming. So ls we do. But this directory which is created, MapReduce WC, it is empty. If I go here, because no code I have pushed. If I add any file there in my GitHub, then I can see. If I add any text file in my I will push the code first in my repository. Create a new file. So here I file, let's say file is created. Okay. So if I want to see in my here, if I do git pull, okay, now ls I do test.txt king. Okay. So that I do. So this way I will commit my code. I will make it repository ready. Then I will show you how to download the code here. So local testing I will do IntelliJ. Okay. But once my testing is done, then I will pull the code and I have to use Maven here because I'm using a Java project. Okay, so Java project we need a Maven. Okay, so Maven we have to install. This is a Maven installment. So Maven is needed if you are using any build tool. Maven is a build tool. Like suppose I want to build my application, so I will use the Maven. My Maven is installed, so I can see Maven version. So I can see here 3.6. So this Maven is installed. Okay, Git I have, Maven I have. Now I can, once my this MapReduce code is uploaded on the GitHub, right? So I can build the project and then I can run the. So that is the easy way to do word count. So the typical output I will see like any word count program. Okay, like if I do any word count program, so I will see like this is the input file and there are some text of line are there. Then I'm using a map function, which is converting each word as a one count. And then I'm doing a shuffling and sorting. And finally, I'm doing the reducer phase and then getting the output. So these all phases are there, but we have to write 3 classes. So when I'm writing a 3 classes, I'm writing one a driver class and another one class is a mapper class. Okay. In this mapper class, I will be splitting the data. So here they have the data is a comma separated. If my data is a space separated, I will remove the comma. I will use space. And whenever my reducer phase, it's just 3 lines of code. These 3-4 lines of code in both map and reduce. Okay. So this code, if somebody asks you write a MapReduce code, so you just no need to remember all these things. Just remember how to write a Java logic to like read a file. Okay, like you have to split the word by space and give each word as a one count. You are giving. So you are using here int writable type, right? Because I told you the data is going over the network, so it should be serializable type. Okay. So MapReduce has 2-3 types of programs are there: partitioner, combiner. Okay. So I will tell about tomorrow all the code setup, right, and how to run the program in the local editor and how to run the program in the Hadoop as a jar. Okay. So we will create a jar of the project and then we will test in our Ubuntu here. We will test by using the Hadoop jar command. So Hadoop jar name, and we give the input file class name, which driver class is there, driver class, and then we give the input path and output path. So input and output. So input path will be your input file will be there and output path will be just direct. And when you run this command, it will run on the cluster and then it will process your file and give you the output as a output form. Okay. Okay, let me show you tomorrow this one, and I will do tomorrow cover Hive and Scoop and HBase. Okay, so these 3, and we'll install Hive tomorrow and Scoop tomorrow. Those are small, pretty small tools to install. Anyone has any question? So MapReduce is a programmatic concept, and basic understanding is good enough in the MapReduce. Like if you understand like how these phases are worked, and what is a combiner, what is a partitioner, what is a counter, what is a map side join in the MapReduce, what's a reduce side join. This theoretical concept is good enough, right? You can explain anyone how MapReduce works internally. Okay. Yeah, we are not using the in live project any MapReduce. Okay, so in the live project, if our MapReduce correct, so there we run on the name of. Can you speak, right, what you're asking? See, MapReduce is name node, nothing is running. Everything is running on the data node. Okay. And I told you the resource manager is allocating the task. Suppose if I take the example of this one, okay, I take the example of this MapReduce word count. So if I say that take the example of this word count program, so I say name node will identify how many mapper machine that data need to be processed. So this map function is run on the data node only. Data node machine by node manager. Okay, this task will be done, this map task, and the same thing that the other data node has, this task will be done. So they are doing their individual task, right? And the resource manager is redirecting to the node manager to do the task on that particular data node. And the name node is instructing to the resource manager. So name node cannot talk directly to the data, this node manager. So name node talks to resource manager and data node. Okay. So data node is a slave. That's the reason it's talking. And resource manager is basically master of node manager who will do the actual task. And the resource manager is talking. Resource manager is talking to the node manager because it's a master. Okay. So name node is first allocating tasks, right? So first name node identified which data nodes have the data for this particular file, this test.txt file, this input file. It identified those data nodes and it has told to resource manager, and resource manager identified those data nodes and told to the node manager to do this mapreduce word count program. So mapreduce word count is copied every node. Okay, every node means all these nodes where the data is there. So this, once this program is everywhere, so not only, suppose here only map function is run, but the program is coming, complete program, map and reduce both, all program is coming, complete program is coming. So whatever it has to use, it will use. Okay, suppose I say these all nodes are using map function, but one node is there in this particular node where the output is coming. So here is a reduce function is used. So reduce function is used on one other data node, where it is doing the aggregation of the all data coming from the different mapper machine. So once finally the data is aggregated, then it is writing the data is being written into the text file or text file. Okay, this is the, did you understand? Okay. Yeah, it's purely theoretical concept, right? To, if you understand what what name node does, what resource manager does, what does data node does, then you can easily correlate here, right? What exactly this mapreduce program, how it will be done, right? By the, okay. And how map and reduce works, that is completely mapreduce part. That is a mapreduce architecture. So if somebody is asking mapreduce architecture, the mapreduce architecture, you have to talk about the 3 phases: map phase, shuffle and sort, but you need to understand these classes. Classes is very important to understand, right? Okay, so this is completely Java class, right? This is a Java class. This is a word count Java, this one, this one. But only class we will run this driver class we run, because driver class is an entry point, and from this class it is executing the other class. Yeah, I will run the program in the editor first. Like I will show you how the word count, because there is no need of cluster. Okay, it is not necessary. Without cluster we cannot run the mapreduce. We can run the mapreduce using the jar. Using the jar in the local editor we can run just for testing. It will not be using distributed computing. It will be just using as a program to test the logic. But when we are copying this program to the in Hadoop cluster, right, and there we are executing the program, then it will be running in the parallel mode, because that is utilizing the cluster. Okay, yeah, so that is the difference. The actual thing we have to run on the cluster only, right? The main goal is the cluster. Okay, so there are the 2 things. One is a testing, one is a like a real execution. So testing is just we do local, right? Even the Spark code we can run locally, Java code we can run locally, but that will not be distributed or parallel cost, because you can't get that feature in the local editor. But when you are creating a jar of the project and then you are submitting a job, a real cluster, then it will be utilizing your cluster resources, right? Memory and CPU. Okay. Yeah, thanks everyone for attending session. So tomorrow I'll cover the other things. Okay. At 9 o'clock. Okay, and, whatever time you have in India, 6:30 p.m. Okay, thanks everyone. And I'll share the
Okay, sir, thank
recording.
you. Thank you so much.
Yeah, thank you, Arvind.